Timeless concepts from Physics Helpline. In this video tutorial, we will discuss a multiple choice question taken from JEE Main Physics question paper of 2023. The question is based on dimensions of physical quantities in which we are required to determine the powers of quantities involved. Read the question carefully. The frequency nu of an oscillating liquid drop may depend on radius r of the drop, density ρ of liquid, and surface tension S of the liquid, as nu is equal to r to the power a, rho to the power b, s to the power c. The values of a, b, and c respectively are. The options are given in the question. We are required to find the correct option. Now for the solution. First of all, let us write the equation of frequency of the liquid drop as given here in the question. Now taking dimensions of physical quantities on both sides of the equation. So dimensions of nu will be equal to dimensions of r to the power a, dimensions of rho to the power b into dimensions of s to the power c. Let's write that. Now frequency nu of oscillations of the liquid drop is equal to frequency is equal to time inverse, so 1 by t. Therefore, taking dimensions on both sides, dimensions of nu should be equal to dimensions of t to the power minus 1, which can be written as m0 L0 t to the power minus 1. Let us remove everything and write the dimensions of frequency as this here. And let us mark this as equation 1. Now density rho is equal to mass by volume, which is equal to m by cube, length cube. Therefore, we can write dimensions of rho is equal to dimensions of m1 L minus 3 T0. Let us remove this and write it here, dimensions of rho. Now r, radius of the drop, r is equal to L. It is the same as L. Therefore, dimensions of r should be equal to dimensions of L1. Let us write it here in that order. We have deliberately omitted t to the power 0. Now, surface tension. S is equal to surface tension S is equal to force per unit length. Let us take dimensions on both sides of the equation. Therefore, dimensions of S is equal to dimensions of F can be written as m1 L1 t minus 2 divided by L is L1. So this L1 and L1 gets cancelled, giving us dimensions of S is equal to m1 t minus 2. Let us write it here and remove everything. Let us write the dimensions of individual quantities along a line so that we'll get space to work out the further problem. Now let us put these dimensions in equation 1. Therefore we get dimensions of nu, that is m0 L0 t minus 1. Here m0 L0 t minus 1 is equal to L to the power a, that is L1 to the power a, and rho to the power b means m1 L minus 3 to the power b, and s to the power c, which is m1 t minus 2 to the power c. Now let us assemble the dimensions of M, L, T on the RHS. which gives m0 L0t minus 1 is equal to m to the power b plus c, L to the power a minus 3b, t to the power minus 2c. So let us remove everything and put it there. Now equating dimensions of quantities on both sides of the equation, we get b plus c power of m, that is b plus c is equal to 0, power of L a minus 3b is equal to 0, and power of t minus 2c is equal to minus 1. Now this gives c minus 2c is equal to minus 1, therefore c is equal to 1 by 2. Putting the value of c here, we get b is equal to, from this equation, we get b is equal to minus c, which is equal to minus 1 by 2. Now using the value of b is equal to minus 1 by 2, we get a is equal to 3b, which is equal to minus 3 by 2. Therefore we get a, b, c is equal to, let us write it here, is equal to minus 3 by 2. Let us remove this. Therefore we get ABC is equal to minus 3 by 2 and B is equal to minus 1 by 2 and C is equal to 1 by 2. This is the answer to the question. This is the answer. Therefore the correct option is minus minus plus. 3 is the correct option. So 3 is the correct option. This completes the answer to the question. Thanks for watching.